Hi, I'm Sean Tierney, and this video is the third session of my 2019 lessons for Java in FRC. The second session, like all even numbered sessions, is in person, so it was not filmed. In this session, I will cover loops, methods, and classes. To work alongside this video, you need to have a JDK and Visual Studio Code installed on your computer. The links for downloading them are in the description below, right down there. I hope you find what you need in this video. Alright, let's get started. So, when we left off last week, we were learning about if and else statements. So we'll start off with a brief, just a quick review. The format of an if statement is if condition, which is a Boolean value, then you do stuff. If condition is true, and else do stuff if condition is false. So that was the format that we learned for the if and the else, and we learned that you could also do an if-else to have it also dependent on another condition, and yada yada yada. So that's where we left off. Now we are going to learn about loops in Java, and a loop is quite a bit what it sounds like. It does something over and over again until it stops. Okay, so if you, again, like last week, if you want, you can type along with me. It's all up to you. I would recommend doing that since it's good to get it in your fingers like that. So the format for a loop, the most simple sort of loop is a while loop. So the format for a while loop is while condition, again, a Boolean value, do stuff until condition is false. So while condition, do stuff until condition is false. So basically, that's just how it works. So a condition might be while true. If you type while true, do stuff, then whatever is within these curly braces will be run over and over again indefinitely. And if you write while false, it's already false, so this whole block won't do anything. It won't even be run even once. So sort of a real-world example of this. Here, let me get to my, here we are. So here, let me try and share my entire screen. Oops. So that you can see this this diagram right here for a while loop. So you will often start with an initialization of a variable. So never mind, I haven't explained this yet. I went to this too early. Oops. We will, what I wanted to do more so is look at this real-world example of what's equivalent to a while statement. So when you're filling up water in like a glass or something, you'll always be checking whether the water is filled all the way. And so while it's not filled all the way, fill water some more. So that's the that would mean you keep going until this condition is false. For this to be false, it has to water has to not be filled. Oops. Water has to not be filled, meaning water has to be filled, meaning you would break out of this while statement, this while loop, and stop filling the water. Does that make sense?
Yes.
Okay. So back to our code. Here. Another use of loops is to work with numbers. So if you wanted to print out all the numbers from 1 to 10, you can do that either with 10, you could either do that with like 10 print statements, or let's make it 100 just to make it so you can't brute force it. So if you wanted to print high 10 times, for example, you would have some counter to start off. You could say int counter equals 0. That's its initial value. Then you would say while counter is less than 100, print high. And so if you do that, no, I'm still missing something. I need to increment it every time. So I need to say counter equals counter plus 1. So that, for example, the first time it goes through, I'll explain this in a second. Let me run it first. Okay. Okay, so as you can see, it printed high a whole bunch of times, which is what we wanted. You could also have it print counter, which will show you that it really does do it 100 times. So it prints all the way from 0 through 99. If you wanted to make it actually from 1 to 100, you would start the counter at 1, and you could either say is less than 101 or is less than or equal to 100, because either way, once it gets to 100, it lets it go through the while loop, but once it gets to 101, it has it move on to the next part of the code, which is the end, in this case. So yeah, 1 to 100. So to explain exactly how this works, we can think of it from the perspective of the compiler, from the perspective of Java reading this. So you can see on line 5, you make a variable named counter and set it equal to 1. You ask the question, is counter, meaning is 1 less than or equal to 100? It is. So you go through and do lines 7 and 8. You do system.out.println counter, which in this case is 1, and then you add 1 to itself, meaning you're setting the variable counter to the value of counter, which is 1, plus 1. So you're setting it to 2. Now is 2 less than or equal to 100? Yes, it still is. So you print out that value, which is 2, and you set the variable counter to 2 plus 1, which is 3. So it goes up by 1 every time, all the way until it says is counter, all the way until counter equals 100. So is 100 less than or equal to 100? Yes, print 100. Counter is 101. Is 101 less than or equal to 100? No. So it goes on past line 10, and it sees it is the end of the main statement, so it stops running. Any questions?
I'm just trying to fix the problem which I've seemingly fixed originally, but it's not. That will only be running programs again, which is rather annoying.
Oh, that's weird. I can only see your mouse again. I think it did that last time.
Is it working now?
Yeah.
Yeah, so it gives me the same error again. I tried to run. I was doing this when I had to rewrite it, but let's see if it goes.
I don't think you're in the right folder.
Yeah.
You're in Documents. You need to be in Java folder.
But it goes
CD Java. Capital J. Oh, maybe it'll work.
Huh.
Well, you're in a folder. There you go.
Yeah. Great.
Wait, why did it just print a bunch of ones?
Oh, if you scroll down, it's probably done.
Oh.
100 of them.
I know why it printed a bunch of ones. Because you didn't put curly braces around the while statement, or around lines 5 and 6, so that it only treated line 5 as what was part of the while statement.
You can probably press Control C. Maybe that'll stop it. No. Yep, there it goes.
It's just going AWOL.
There
There we go.
There you go. Yeah. All right. So now I'd like you to print all the way from 100 to 1, meaning do it backwards. See if you can figure that out.
Is this correct?
It
Starts with
looks like, yeah. All right.
It could all. I didn't realize all didn't listen. He just didn't pull up.
Yeah. I texted him, but he's not responding, so.
Okay, there we go. 101. Change that to 100.
All right. Great.
I did not sleep last night.
That is a-okay. All right. So that's while loops. Now we're going to talk about the other main sort of loop, which is a for loop. For loops are used mainly as a shortcut for doing exactly what we just did. So the format for a for loop is for parentheses, what do you call it? Initialization, semicolon, condition, and incrementer. And do stuff. So I'm going to explain that by referring back to our example. So in here, when we have int counter equals 1, that's our initialization, because we're initializing this counter variable. Our condition is what we're using in these parentheses in the while statement. Counter is less than or equal to 100. So it'll go in this for loop until this condition boolean is false. And the incrementer is what's used on line 11. By the way, to make it a little easier, a shortcut is counter plus plus, which will add 1 to itself automatically. Another way to write it is counter plus equals 1. And if you do this format, you can do it with any number, 3 or 6 or negative 54. But counter plus plus is the syntax specifically for adding 1 to itself, which is a lot of what we do in these for loops. To further explain it, let me refer you to that diagram I sort of jumped the gun on. Right over here. All right, so it comes in from the rest of the code, and it does its initialization. That's this. Oops, wrong window. That is this line 8 right here. Int counter equals 1. Then it goes through, checks the condition. If that condition is true, it does what's inside these curly braces, inside the body of the while loop. And if it's false, then it skips straight to the end of the loop, past this second curly brace on line 12, and it does whatever else is in the main method. And if it's true, it just repeats, and or if it's I already told you that. If it's true, it does the code inside the body of the while loop, and then checks it again, so it'll keep going. But we already knew that. That's just to review. So the for is just a little quicker way to do that. So if we just say for int counter equals 1, so that's this initialization line. Initialization. This condition counter is less than or equal to 100, and this incrementer would be counter plus plus. And we can replace this do stuff with actually doing stuff. Printing counter. So we can put it into that name, into the main method. Here it is. Okay. So that here we are, int counter equals 1 and all that. when we run it, it should have the exact same output as before. Which it does, all the way from 1 to 100. Does that make sense how the for loop syntax works?
Yeah.
All right.
Yes.
Now I'd like you to modify this one to make it print from 100 to 1. Print them all backwards.
I'm trying to make sure this works for me the correct way.
Right, there we go. And counter minus minus works as well.
That it does. So, Ivan, I think you have an extra curly brace on line 13.
That's it.
And there's also an extra semicolon on line 4.
There we go.
Okay. So, well done, both of you. Just by the way, when you want to do something a certain number of times, I've often found it like kind of hard to think about. Oh, do I like? Is it 99 or 100? Like you have to think about both. Are you starting at 0 or 1, and are you ending at equals to and or less? Are you ending at less than or less than or equal to? So you have to factor both of those in when thinking about it. So often what I like to do is just start at 0, take away the equal sign, and then just have this one number be how many times you want to do a certain thing. So this way I know for a fact it'll print whatever it is 100 times, because it will go from 0 to 99. So that's just a nice standardization to make it a little more foolproof. Okay, so that's loops mostly out of the way. That's the basics of loops. Now, the more important topics at hand are functions and classes, which we'll get to right now. All right. So if you haven't already, make a new file and call it functions.java. You can have it as public class functions. So oh, I suppose we could call it, we should call it methods, because that's generally what people, the word people use to refer to it in Java specifically. Since everything is object-oriented, and these are all going to be part of a class. Here, let's rename this guy. Okay, so to start out, I'll tell you how you can, first of all, what a method is. You know what, I'll ask you guys, what do you guys think a method is, or a function, as it's called in other languages?
What? a way to run some code without having to type it out? Because you can only type it once and you can call it later.
Yeah. Well put. So it's a time saver basically, and it can also function as a way, like, it's more versatile than like a loop, for example, because you can give it information to make it output different things. Which I'll explain that in parameters in a little bit. First of all, let's just start out by making a simple function. So up here inside the class, but outside the main method, we can make a public void greeting, or public void greet. It should probably be a verb to make it clear that it's doing a thing. Okay. I forgot to tell you the format. You can sort of see it in here. For most functions, it goes the word for the scope of the function, the return type, and the name with parentheses and parameters in those parentheses, and do stuff. Return if necessary, or if not void. So let me comment that out. So there's a lot of stuff in that format that I'll get to it all one by one. For now, a basic function, you can call it the words public void, and then the name, and then just open close parentheses. This means there are no parameters. And then we just do stuff in these curly braces in the body of the method. So public void greet, you can have it just simply print out hello, how are you? Lovely weather today. So that you can, if you can, in this case, call a method. In order to call the method, the format is that method's name and the parameter values, semicolon. And since this has no parameters, again, we're just going to have that open close parentheses. So simply greet, open close parentheses, semicolon. Yeah, save. That'll probably.
For some reason, it's not. Whenever I put void, no, whenever I put void on his screen, like it turns green, right? But for me, it just stays as white text, and greet also doesn't change.
Oh, maybe because you haven't, like, you need to finish writing the whole method. That might be it. Oh, it turns green immediately for me. I don't know.
Yeah, me too.
Huh. That's strange.
Okay.
Yeah, Okay, because it won't let me run the print inside of it because it's not working.
Yeah, mine is not working either.
Yeah, let's see. Mine isn't either. I have to be missing something. Okay. Cannot be referenced from a static context.
Yeah, I have the same error.
Yeah, so if we call it public static void greet, that will probably fix it. Yeah, it did. Okay.
Yeah, that's good.
I'll explain the concept of static a little later. That requires knowing about classes. So we can call it public static void greet. We did all this, and that way we can just say greet however many times we want instead of having to type all those 3 lines every single time. So that saves quite a bit of time and effort like this, and it makes it more elegant. So the main reason we would use this is because the main reason we would use methods is for their versatility. So that can be used with parameters and with returning stuff. So you can think of it as input and output to a method. We'll start with the input. The inputs meaning the parameters, which is basically just variables that you'll pass to a method. In this case, we can say a string variable to make it more personalized, and we can have it actually call you by your name. So we could say hello plus name plus a period. How are you? Lovely weather today. And so now you can see greet is underlined because it needs a parameter, but we haven't given it one, so we'll give it a string. Sean, Ivan, oops, and greet Caden, just so it gets to everyone here. So it says, hello Sean, how are you? Hello Ivan, hello Caden. Okay, so does that make sense how you can give it information like that?
Yeah.
Yes.
Okay, great. So now where it really gets useful is if you don't if it's not void. So this void, that's this return type. Void, the word void means return nothing. So let me explain what returning is. Like I said, it's an output of the function. So I like to use a metaphor of a pizza delivery guy. So let me first make a method that returns something. We can just modify this one to return a string instead of just printing it. Let me get rid of these ones or comment them out for now. So instead of having it system.out.println, we're just going to say return return hello plus name plus period. And it'll just, I don't know if I've explained this before, but the pluses, when it works with strings, pluses just smoosh the strings together. So if like you saw here, if your name's Sean, then it will say hello, comma, space, Sean, period. So when you return it, we can then print it here in the void method. Oh, oops. Print it here in the void method. And then we can do this with everyone's name. Hello, Sean. Hello, Ivan. Hello, Kate. So it worked perfectly. So, now to explain the concept of return. Like a pizza delivery guy, when you call a method, that's the same thing as calling a pizza place and ordering a pizza. So they send a pizza delivery guy. You give them all the information, meaning like your name in this case, and they do their whole process of making the pizza, and then they end up giving this pizza to the place where it was called from. So this greet method, it gives this hello plus name plus period to the greet method where it was called from. So as Java reads this, it replaces the method call with the value it returns. Does that make sense?
Yeah.
Okay.
Yes.
I have to fix my code.
Okay. So you can return pretty much any type of variable. I'll show you with some numbers. You can return. Here, I'll keep this one. And I'll just make another one. Public static int. How many roads?
It's giving me a strange error.
Giving you a strange error.
There, I think I gotta fix it. No, it's still going after this curly brace. 1.7.
Going after that curly brace. That's.
Yeah, so every time.
Oh, I know. Void is capitalized, and it shouldn't be. It's weird that it picked on the curly brace.
Yeah, it autocorrected void to be capital.
Huh.
There's a space between greet and the opening.
Yep.
There it is, yeah.
What?
It's not out that
There's
print
a
line.
red on the print line.
I know what it is. It's because you're. It's because now you're trying to print the output of a void method, and it doesn't have an output. So, yeah.
So what do I need to change?
You would need to simply. Well, depends what you want to do. Do you want to do what I just did, or do you want to do what I did before? Okay, so then you need to. You can look at my screen for reference. You can change that void in the top method to an int, or sorry, not an int, string. And then type return followed by the string value, just like how I have it. And now it should work. Hello, Yvonne.
So I put the space there.
Okay, great. So, as I was saying, we can do it with any sort of variable. So an integer, for example, we can ask it how many roads, like how many roads must a man walk down? And it would just return the value 42. So in this case, you can just print how many roads like this. So it does this full method call, calls the pizza delivery man, and he comes and gives us that 42 pizza right to where it was called from. So that's equivalent to saying print 42. Let me save it and run it. It indeed prints 42. Like that. Okay. So you don't want your name inside parentheses, you want parentheses after it.
What is its control?
All right. Also, by the way, the convention for methods is just like for variables, where you do camel case where every word is capitalized. The beginning of every word is capitalized except the first one.
Except the first one.
Right. So that the capitalizing only serves to separate which word is which. So you can also return a sum. I meant to say you can also return an integer by taking in a few variables. So you can take in int first and int second for a sum method like this. And in here, all we have to do is say return first plus second. In this case, it's basically pointless to make a method like this in real life, but I'm using this to explain it. You can comment this one out and print out that output. So print out sum of 3 and 4. And so, as we would expect, it'll print out 7. 7. Okay. So, referring back to our template that we made, now we know more about the return type and the parameters. It makes more sense, right? We have the scope, usually public for right now. You just say public, the word public, whatever return type it is, whether it be string, int, or void. and then the name of the method, whether it be greet, how many roads, bar, foo, whatever it is, and then the parameters. You could have no parameters, 1 parameter, 2 parameters, however many you need. So the inputs here, this gives it the type and what inputs it needs, and this gives it what it needs to output. That's what that return type is. And it does all the things, including returning stuff if it needs to. Does that make sense on how methods run? Okay.
Yes.
Also, by the way Java compiles, you can put any of your methods anywhere in the class. Just don't duplicate them. You can put them anywhere in the class, and it can still access them. So if I have it down there, you might think it would just read from top to bottom, but it will, if a method is called, it doesn't know what it is, it will search the whole class and it finds it, and it's totally fine. Some other languages don't work like that, but this one does. So that's that one. Doubles are pretty simple. It works very similar to how ints do in this case. How about, just to retouch up on a certain concept, let's make a public static double, so that'll return a double. We'll call it divide. Int first, int second. So it'll divide two integers, and it'll give us the ratio, the quotient of them. We can have it just return. So I'm going to start typing this, and you guys, I'd like you guys to tell me if there's anything wrong here. Either
I don't think so.
everything's right? Sure about that?
I don't see a reason why it wouldn't run.
It'll run, but will it produce the desired output?
Well, apparently not, because mine just went crazy. Oh, no, I know why. Never mind.
Okay. So,
So,
all right. Where's my terminal?
does it
There it
have
is.
to do with the double and the int?
It does. Also, I did other compile errors or something.
This just gives me 0.
Yep. You remember how to fix that?
Unfortunately, not really.
Okay. So that has to do with casting that we went over. We went over it quite quickly, so I don't blame you. But all you have to do is,
I don't remember that.
yeah, all you have to do.
Actually, I tried doing that while I was at your place, and it didn't work. But
Yeah. So all you have to do is write double in front of it, and that should work just fine, and print out 0.5.
yeah, I tried doing that last time, but it didn't work.
Oh, that's weird.
It's weird.
It's probably something else wrong. So basically, that turns this first one into a double from an int. It doesn't alter the value of the first variable, but it changes this expression from int to a double, meaning it makes it treat it as a decimal. And when Java tries to divide two ints, it rounds down to the nearest int, but if at least one of them is a double, then it will actually treat them as decimals. Does that make sense? Okay.
Yes.
Okay. So, just for the heck of it, I'd like you guys to make a subtraction one, like a minus method, a difference method, whatever you want to call it.
Whoops, I don't want to do that.
Public. Okay.
Alright, so yeah, that's good.
Wait, no, we have to have the. Do you have to double it when you're subtracting, or is it only when you're dividing?
It's only when you're dividing.
Okay.
It's only when you want decimal. So like if you're dividing 10 divided by 5, it'd still work normally. Okay. Okay. Okay, looks like you've both got it. Next, we'll make a method to print out the largest of two numbers. Not to print out, but to return the largest of new numbers. Okay. So here we'll actually have to use some if-else stuff. There is an easier way to do it, but just to revisit the concept, let's do it this way. And we're going to return first. All right, get largest. We can make it 4 and 4 and 6. Eight and 6, 6 and 6, just to do all the cases. Hopefully it works. All right. So in the first one, I asked it which is bigger, 4 or 6, print 6. Which is bigger, 8 or 6, prints 8. Which is bigger, 6 or 6, print 6. So all of them are right, and it works. All right. Do y'all understand this logic?
Yeah.
Okay. So now I'd like you guys to have it print the smallest one. Yep. I'm going to move this stuff back above the main method so you can see it and the main method at the same time.
Okay, good.
Okay. Awesome.
Got it.
Sounds good. So, by the way, the return keyword makes the function not run the rest of the function. It's phrased a little weirdly, but oh well. That means that we don't actually need this else, because if the first is greater than the second, then it will return the first, and then it will exit from the function and go back to where it was called in the main method. And if it's not, it'll just go straight to return second. So this will also work the exact same way. 686 did the same thing. Also, there's one other way to do this, which is this is only one line instead of 4. That could have been 2 lines if you didn't have the curly braces, but anyway, this is only 1 line instead of 4. You can do, or instead of 2, return math.max of first and second, which means we didn't even really need to make this function. We could have just called that right where this is. But that's the way it goes. This math class is actually very useful. It has a lot of cool stuff. I'll just show you a little bit of it. So you could have it print out math.pi, and it just has that as a constant. Has hello. Oh, I didn't save it. There it goes. Prints pi. Has like math. What all does it have? You can control click into it. It has a bunch of stuff in here. Degrees to radians, radians to degrees. It's got sine, cosine. It's got all this stuff. Arc, cosine, logs. It's very useful. Has a bunch of math in there. Anyway, back to the topic at hand. We've done strings now. We've done a bunch with numbers. Now let's do a little bit with booleans. Okay. Public static boolean. We can call it is greater than 5, or yeah, is greater than 5, and we don't need to pass it anything. We just return the value of. Oh, we do need to pass it anything. We do need to pass it the number. Return num greater than 5. Oh, forgot to call it. Okay. Is greater than 5. For a long title like this is why I love autocomplete. 7. And 5. Let's just test it with those. True, false. Just like we thought. 5 is not greater than 5. 7 is. Okay, so now that you have that. So by the way, first, before I give you something to do you both understand like how this works? That you can just say return num is greater than 5. How that syntax works?
Yes.
Okay. Quick review, just the fact that that comparator is a way to convert things to a Boolean, so it converts these two numbers to one Boolean value that it treats as a Boolean and passes to where it was called. So now I'd like you to change this to, instead of is greater than 5, we can just have like is greater, and just generalize it so it doesn't have to be 5, and you can call it with, wait a minute, hold on, we basically, well, no, it's slightly different than get largest. Yeah, make it just is greater, and have it so it doesn't have to be 5, it can be any number in that place.
There you go.
I don't mean like one specific number. I mean make it so that you can call it with any number you want.
Oh, okay. Alrighty.
Okay, good job, Caden.
Alrighty.
Okay. Now that we have that, let's just do a quick is divisible by 3, and then we'll be done with booleans for now. Well, I mean, you all remember modulo. We can skip this one, right?
Yeah.
Okay, because we need to get onto our classes. So a class is basically a blueprint for something. I'll just start off by making a class, and I'll explain it from there. By the way, we've been making classes this entire time. We just made a public class methods that we've defined as everything in the whole file. And we did that for loops, we did that for hello world. The only thing is we haven't made instances of these classes, which I'll get to later. Just remember the idea of a class is a blueprint, and an instance is something you make out of that blueprint. So public class animal we can start with. So a class tends to have fields and methods. So a field is a variable that belongs to a class. So you can think of it as attributes of that class, attributes of that instance. So, for example, what might we have as an animal, sort of an attribute that all animals might share? We might have a certain number of legs, right? We might have a Boolean has vertebra, or vertebrae, not sure. And we have, I think that's okay for now. So those are some fields. It also has a constructor. It tends to have a constructor. And the format for that is just saying public, and then the name of the class. So with normal, this is different from normal methods because it does not include a return type. It doesn't say public void, doesn't say public double, or anything like that. It just says public animal, and then we might input a certain number of legs and whether it has a vertebra. So you can say number of legs to have it different from that name, and has a vertebra. Oh, forgot to say int and boolean. All right. We can now set num legs equal to number of legs. It's important that you have it as the field set to the local variable because we're actually changing this guy's value, and we don't care about this guy's value, so we're just taking it in rather than changing it. And same thing with has vertebra equals has a vertebra. Okay. So that's the constructor. I'll get into why that constructor is important a little later once we're making instances. And now we have methods down here. You can say public void eat yum. System.out.println yum. You know, we could actually have, let's have another one. Let's have it as a size, as an age, int age, let's say in years, as a comment, and double size in, or weight, we could call it, in pounds. Because we're Americans, damn it. I mean, dang it. So when we eat, we can say like weight plus equals, meaning it's adding whatever to itself. You know, we could even have it as, you could give it a certain amount of weight that it gains. Double weight gained. And public void pastime. Int years past. Int age plus equals years past. So these are stuff that you would be able to like do with this animal. So we can let's make a new class, a new, what do you call it, file, and call it, we can just call it classes. Oh, great. Now I'm going to have to type public class classes. That's gross. Okay. And here's where I'm going to initialize it. I'm going to create an instance or an object of this animal class. So to do that,
I didn't get all the animals, so
oh yeah, I can.
Okay. Okay, I got it. I can type some what you talk.
Oh, oops. Shouldn't have that int there. Okay. And here, let's make a main method. And I'm going to, by the way, it is important that you have those two files on the same like directory level. So like both of them are stored in documents for me, so it'll work fine for me. Just make sure that's a case for you. You can call it animal because it's Java's case sensitive, so it'll see these two things as different things. We'll use this keyword new and animal. And so this, here, I'm going to write a template for this instantiate sort of thing. So it's going to be the class name, and then the object name equals the keyword new, and then the class name parentheses constructor parameters semicolon. So when you make a new instance, you are essentially calling the constructor function, and that makes it run this constructor. I still need to set these values. So number of legs I can set to 4. Has vertebra I can set to true. And so now here it is. It's a class. The problem is we don't really have a very good way to check up on a lot of these values. I mean, we can print them directly. So, in fact, let's just do that real quick. We've made this animal object, and we can basically print out a lot of its variables. So we can print out animal.age. The dot or period means I'm going to be referencing a field or a method that belongs to this object or class. So print the age that belongs to the animal in this case. Print the value of this has vertebra variable in this specific instance of animal. Okay. Let's see, we did age here. I'm going to do age down here. Num legs here. And weight here. And then we can Well, first let's try running this. I made some errors somewhere. New animal or true. Cannot find symbol. Cannot find animal.
The same thing happened to me.
I'm just trying to catch up. I just can't even finish the animal one because I got stuck on them.
Right, I should have checked that you were finished. Okay. So here they are. Yeah, I thought that would be okay, since they were in the same folder. One way to fix this is just copy-paste animal and put it in classes as a separate class. And so that way we don't have to think much about it. Okay. So it printed out 4, 0, and 0. Okay, so by the way, we forgot to initialize all our variables in the constructor. So we should set age to 0 starting off and weight to 0 starting off. And so it did the right thing by having them as 0, since when you do this in this context, it sets all those fields to its default values, which is a 0 in the case of an int or double. But it's not a good idea to take that chance, since we're trying to access a variable's value without initializing it, and that's typically not a good thing. But now that we have initialized all our methods, we should be good to go. So there are a few other modifications I'd like for us to do to this class, this animal class. It's generally not a great thing to access access fields directly. Usually we'll want to use what are called getters and setters, and they're pretty self-explanatory. By the way, I am going to explain some of what this scope means of classes and variables and instances. So public class animal up here, we say public, and we also say it in front of all these methods. That means it can be accessed by pretty much anyone in the Java project that we're in. So I'm not quite sure why it wasn't able to access this file, but oh well. Oh, I know why. You should be able to just say import animal, maybe .java. Wait a minute here. Let me see if it can do it for me. Let me comment this out and well, what's weird right now is that animal is not like underlined like that. It doesn't see animal as a problem until after it compiles. So that's Very weird, but we have limited time, so I'm not going to try and figure that out right now. Okay. Oops. Animal.numLegs. Oh yeah, because I made this private. So that means that only stuff within that class can see it. Public, that's what this private means. So it's generally a good idea to make your fields private, and you can make public methods to access them. So if we add the keyword private in front of all of those declarations, and then we can start setting, or start using these getters, or accessor methods, as they're called. So we can say public void get numLegs return numLegs. You'll do that. Not public void, my bad. Public int get numLegs. And then you'll do that with all of them. Public boolean has vertebra. Return has vertebra. Public. Oh, I'm not sure if that's okay, as to whether it's okay that these two have the same name. It's probably fine, but just to be safe, I'm going to say get has vertebra. Since it has these two, since it has these parentheses to distinguish the syntax, it should be fine, but either way. Public, what was it? Public double? Yeah. Public double weight. Return weight. Okay. So now that we have pretty much all of that, that's weird. What's wrong with this? Duplicate method for the method, modifier for the method. That's weird. Okay. That this isn't treated as a comment. Oh, I got it. Because we have a random public here. Okay. I meant to call it get weight. I mean, it'd probably be fine. I am curious to test that out after we run it as is. There are some other errors. Oh yes, because now we're still trying to. Now we are still trying to access these private fields, which we can't do that. So we need to access the public methods. So .get numLegs, .get has vertebra, .get age. Wait a minute. Oh, I forgot about public int get age.
Wait, so what's the private? Why do you have to use the private versus public?
Well, it's you generally you don't exactly have to make these private and have them have public accessor methods like this, but it's good practice to so that you don't accidentally you know, I'm actually not completely sure why it's such a no-no to why it's such a no-no to have these as public and have them accessed directly. But I don't know, I've just always been told that it is, and you should use getter methods. Okay, so this is a lot. You don't have to type everything, just make sure you understand it, and make sure you've typed the this, line 6, the actual instantiation. Okay. So does this make sense so far as to how this stuff works?
Yes.
Okay.
I did do way tubes.
Happy pie time, everyone.
Every time.
Yep. Okay. So, whether you're done or not, let's move on to the next concept, which is static methods and the keyword static. So you've seen static before in the main method. So you can think of static as meaning this thing does not belong to the object. It does not belong to the instance. It belongs to the class. By the way, instance and object are, at least for the most part, used interchangeably in Java. So I'm going to make a static method and a static field, like a static variable, as part of this class animal. So I'm going to have it as private static int num animals. So this is an attribute that won't belong to one specific animal, but it belongs to the blueprint of an animal, basically. And then we can just have a static, let's put it underweight, underweight. We can have as a static method here, public static int get num, what's it? Get num animals. return num animals. So, in order to use this in the constructor, all we need to do is say num animals plus plus. I'm going to say private static num animals equals 0, so that it starts out as 0 and it just adds 1 every time a new animal is constructed. So let's test this out. First off, do you understand what static means now?
Kind of.
Generally, this should clear it up. This should help a bit.
Pretty much.
Here, I'm going to call animal. I'm just going to rename this so we can make multiple of them. Just going to rename it to just A. So we can have animal A and animal B. So we can have animal B equals new animal with 2 legs and with no vertebra. Animal C with 3 legs and a vertebra. And that should be good. Here, we can. I'm gonna comment that stuff out, and I'm going to just have us between each of these lines. I'm gonna print out animal dot get num animals. So, oh, an important thing to note is that, let me uncomment these real quick so they're easier to see. When you are dealing with non-static methods, so just normal methods that belong to the object, you say the object's name dot the method's name. So in this case, A dot get num legs, and any of those, since none of those methods have the static thing attached to them, and since get num animals does, you call it with regards to the class as a whole. So rather than saying A dot get num animals, you say animal with capital A dot get num animals. Okay. And I'm just going to print this out between all these lines so you can see how it increases. Hopefully it works. I'm saying return statement on line 58.
Okay.
Get age, right, I forgot. Return age. Now that should be okay. All right, 0, 1, 2, 3, and the 4 is getting them legs, so it just goes 0, 1, 2, 3, ends up at 3, just like we thought. So, does that make sense?
I'm trying to get all of it down.
Yes.
Okay.
The line is good. It looks.
Okay. Well, it doesn't matter all that much whether you have it completely typed out. The main thing is whether you understand it. And so, whether you're finished or not, I am going to move on to this final topic, which is subclasses. All right. So, a subclass, there are these things called subclasses and parent classes, or subclasses and superclasses. So I'm gonna start making one, and I'm gonna try and explain it as I go along. So I'm gonna make a different class called dog, and it's going to extend. It's using that keyword extends animal. And so that means that it'll have all the attributes. It'll have all of these methods, all of the ones that are public anyway. Also, let's change these privates. Yeah, let's change all of these to protected. And the word protected is a different scope. That means these things can only be accessed by its by what's in that class and what's in all of its subclasses. All right, so class dog extends animal. I'm gonna have. I'm wondering, can you say constructor? Nope. Oh well. I was wondering if there is a shortcut for that. I'll just write it out. Public dog. Int number. No, we don't need an int number of legs because we know it's going to have 4, and we know it has a vertebra. Let's just make it an empty constructor and just make sure we call super. So basically that means the word super means refer to the superclass. So when you type super and open close parentheses with stuff inside it, that means call the superclass's constructor right here. By the way, are you guys on a tight schedule, or do you mind if I go over 2 hours a little bit?
That's fine.
Okay. Could probably go over a little bit.
Okay. It'll probably be like maybe 10 minutes over. So like 3:40-ish. So this constructor calls the superclass's constructor. Passing it 4 as its number of legs, and true for has a vertebra. Okay. And here, let's give it some dog-specific fields. So we can have it as private string name, and we could have like a, I don't know, could just have like tail length or something. Double tail length in inches, and sure, that's all we need. You know what? For the heck of it, let's have a private boolean is good dog. Okay. So this way it can objects of dog, instances of dog, can now access all of these getter methods. They can access this eat and this pastime method, and it can access whatever methods we're about to give it. Say public void bark, for example. We can do a sys out and print bark bark. And now we can do a getter method to access each of these things. So public string get name, return name, public double tail length. I mean get tail length. Return tail length. And public boolean is good dog. All right. We could have a public void. Let's change some of these in different ways. We could have public void grow, and that can we can pass it a value for how much its tail has grown. I don't know. Tail length is a weird one to choose. Why not just change it to length, right? Length of dog. Okay, so that we can have row int length increase. Length plus equals length increase. Remember that that means length equals length plus length increase. So it's adding it to itself. And we could have one more as public void raid pantry. That will set all right, two more. Raid pantry, that will set good dog equals false. And public void sit sets it back to true. Okay. So, oh, we forgot to set these values in the constructor. Okay. Give it a string name, double length, and boolean is good dog. So I'm going to that was not English. I'm going to teach you a new keyword, which is this, literally this. So the keyword this refers to whatever instance is accessing this method. So let's say, for example, we're already trying to create a dog, and we call it like D, and we call it D. That would refer, this .name would refer to this field, and that is a way to differentiate it from this local variable. So that way we can say this .name equals name, and this .length equals length, and we don't have to have them as two separate names. Does that make sense?
Yeah.
Yeah.
Because if we didn't have this dot, then it would try to set the local variable to itself, and it would basically just do nothing. By the local variable, I mean the one that is only accessible in this method, as in string name, double length, or is good dog on line 89. So that should be all for this dog class. And in the main method up here, I'm just going to comment this out and just start typing down here. We can refer to our template here. So the class name is dog. The object name, we can call it dog with a lowercase d, and equals the keyword new, and then the class name dog. We can enter to now input these parameters. So as the name, we can call it Fluffy. As its length, let's call it, it's a little one, so we can call it 10 inches. And is good dog, we'll start it out as true. Okay. Now we can so we can see if we take these back and have it as instead of a.getNumLegs, we can call it dog.getNumLegs, and all of those. So we can see all of those are still accessible, and then we can do that for each of these variables. This part is just tedious, so if you don't want to do it along with me, you can just watch along and see if it works.
Well, I need to finish the dog section.
Oh yeah. Okay. here. Wish I could like freeze my screen so I could keep typing this, and here, I'll just try and quickly get through it. And what is it? Get length and get oh yeah, is good dog here. Okay. So it still could access all of those variables. 4, true, 0, 0. Fluffy is his name. 10 is his length in inches, and is good dog is true. Now if we want to test read oh, we don't want to print that actually. We just want to say dog.raid pantry, and we want to say let's just print is good dog again. Now if we save and run, it should be the same thing except to change it to false, like that. So that method works well. Here, Ivan, do you want me to go down to?
Yeah, it's just so I can see that it works. Because I have I have those right now.
Okay. So does it make sense as to like how these how subclasses work and why they can be useful? Okay.
Yeah.
I'm going to show you a little example in robotics for a subclass for like why this is useful. Let's see if I'll got it down.
I think I've almost got it all. Yeah. Okay, now I have the dog section written out.
Okay.
I have to write the actual function. I never got to run anything.
It's not really, only line 19 is really that important. The rest was just for me to make sure that it worked.
Well, I mean, like, just the original animal.
Oh, you didn't get all of that? Okay.
Oh, no, I got all of it, I think, but I never got to run it.
Okay.
It's giving me a lot of errors.
Oh, yeah?
So I missed a bunch of stuff.
Oh, Caden, I see your dog constructor, yeah, is, should be capitalized.
This.
Yep.
It's green. So this constructor name.
Okay. Here, I'm going to, how about, you can, like, fix up all of that, class on your own time. There was, dang it, was there one other thing? Was there one thing that I wanted to cover? Okay, oh yes, there is. How, objects and instances work. So, and like their relationship to just plain old variables. So I'd like you guys to just fix up those classes on your own. I'm going to send you all my version of this class so you can, of my classes class, so that you can all see the difference between mine and yours. So for right now, one important point is that objects do not work in the same way as variables, because with a variable, you would just give it a value to put inside that box. But with an object, you're essentially creating a new thing with that, in this case with that dog blueprint. You're creating a new thing after the equal sign, and you're basically having this dog as a pointer to it. So one way to illustrate this is if we were to have dog 2 equals that original dog, and then we were to do something with that second dog here. So like, for example, if we were going to say dog 2 dot raid pantry, then that should be that should, you would think, only deal with dog 2. However, it will instead set the values of both dogs, because really there's only one dog, which is this new dog Fluffy, of length 10, and who is a good boy. And so since there's only that one dog, you're just referring to it with two different expressions. So it's kind of like one person with two different aliases. When something happens to that person, it's not like it's not like Clark Kent and Superman are gonna have different reactions to it. They're both the same person, sort of thing. So if we go through this and run it, then you can see both of them are set to false. So does that make sense? You're only ever creating anything with that new keyword. All right. So I think we've gotten through everything that I wanted to get through. I think this is a good time to end it off. Anyone have any questions to finish it out?
No, I just need to. I'll finish the dog section and the printing.
Okay. Get all that syntax in order. Cool. Are you both going to be here on Thursday?
Yes.
I think so.
Okay, sounds good. Well then, I will see you guys then.
Alrighty.
Goodbye.
See ya.
Yeah.
Hey guys, thanks for watching. I hope this video is helpful, and I'll see you in the next one.